Hey, Brainiacs, what do you do when you sit down, crack open your book, start working some problems, and then all of a sudden you get to, let's say, problem number 10. You look at it and then scratch your head, and at that moment you realize you are stumped. Where do you go from there? How do you solve the problem? That's what we're going to talk about today. So here we are, problem number 10. So what do we do first? I first reread the instructions one more time while breaking them up into pieces and defining each word in the instructions in my own words. I will then rewrite the instructions and question to the problem in my own words. Physically writing out the question in your own words goes a long way toward organizing your thoughts. After that, I will then ask myself, out loud, what do they want me to do? In general, I want to know what the answer will look like when I get it. I want to know what the answer is representing. And the general answer will come from the question. More about that a little later. But generally, try to have an image of a solution before looking at the examples. Next, I go to the examples at the beginning of the section to find an example that is a close fit for the problem that I'm working on. Analyze how the example is the same as the problem you're working on and how it is different. For instance, maybe your problem has fractions and the example doesn't. Or maybe slightly different words were used. Just take notes on the similarities and the differences. The idea behind the system of solving a tough problem is that we're attacking this problem as if we're writing a report about this one problem. Once I've chosen my similar example, I then study that problem for thorough understanding, adding extra steps in the book, in the margins, if needed. If the margins in your book aren't filled at least a little, then you're not studying enough. You really should be rewriting that book in your own personal mathematical language. Writing notes in the margin, rereading them, erasing them, and then rewriting them. Always ask yourself if the steps could be broken down into more steps. In addition to that, you have paper separate from your other homework problems with notes devoted to this one problem alone. Problem 10. Adding steps also goes for class notes. I remember way back when I was at the university and multiple professors would have examples that seemed to move from step 3 to step 10 in one fell swoop. Always very few intermediary steps. It was so common that graduate students called it hand waving. Sometimes I remember sitting there thinking, yeah, that was a pretty good magic trick. Now can you take me backstage and show me how the trick is done? Just remember, the advanced guy needs no steps. They know the idea and how to produce a solution with very little pencil lead. The beginner, on the other hand, has an idea, but generally has no idea how to get there. So if we start a problem as a beginner and want to be the advanced guy who skips steps and seemingly does magic, then the transition lies in the intermediary steps. The intermediate is literally the process of mediating in between you, the beginner, who knows very little, and the advanced person who has given you direction and very few scraps of knowledge. You are always the mediator. You mediate by developing a roadmap of logical and understood steps to get to your destination. The short-term destination of solving the problem and the long-term destination of becoming the advanced person who is an extremely strong mathematician. Even when you become advanced, never stop writing in those intermediary steps. They really help your mind to focus like a laser beam. Keep in mind that the intermediate level is the most important, but also the most underrated level in all endeavors. The intermediate level is the overlooked Jan Brady, middle child of the family. But without it, there would be no advanced level. Just think about anything you got good at. As a beginner, you dreamed of being advanced. Pushing forward, the intermediate you did all the hard work necessary to keep pushing forward enough to be advanced. Then one day, whether it's a sport, a language, piano, or mathematics, if you've been advanced for long enough, you started to skip steps. After a while, it just seems that the hard work you did as a kid to learn something, for example, long division, just came naturally. Like I mentioned in the last video, you forgot where you came from. You forgot the intermediate you, the guy who did all the work, all the hard work. Never forget the intermediate you, because that part of you is the strong, courageous, and durable you that gets things done. Okay, now you've studied an example and added steps. Next thing I do is make a list of the mathematical tools that I need or might need to work this example. I used to make a special column and then I'd box it. The list could be things from the section you're working on or from previous sections. For instance, if a math problem is asking you to find the zeros of a quadratic equation, then for sure you should be writing down the tools of factoring and completing the square. If a math problem is having you divide a single digit into a 5-digit number, then you need to have the tools of subtracting, multiplying, and dividing. Just write down off to the side the tools you'll need or think you'll need to get the job done. Now that you've studied the example problem and have written down the needed tools, now it's time to get to work. Grab a blank piece of paper, read the instructions to the example, quickly write the instructions in your own words, and attempt to work the example on your own. Talk to yourself out loud as you solve it, almost as if you're teaching it to someone else. This self-talk, as you physically write down the steps and visualize them, deepen the grooves, the strong storage units in your brain. If you solve the example on your own, then you have succeeded in fortifying your foundation. You're ready to move on. If you don't succeed at solving the example problem, try studying and breaking it down some more until you can do it from scratch. We must be able to clearly and efficiently solve the example problem if we're going to even have a chance at solving our problem number 10, that intractable problem number 10. Now I'm ready to think more about that stubborn problem number 10. So after solving the example problem, I go to problem 10, and like I briefly mentioned before, I write down what an answer might look like. Is it an answer like x equals 12, or is it a format like y equals 3x plus 7, or 14 minus 4 cosine x? Again, it helps to understand what the ending should look like. Of course, it definitely wouldn't hurt, after writing down what a solution might look like, to look at the solution in the back of the book. As a matter of fact, we really need that solution to be there. We need that solution to know that the technique we have administered is correct, especially when you're struggling. If problem 10 doesn't have a solution in the back of the book, I will first probably work one of the end caps that does have a solution. In other words, work problem 9 or 11 if it has an answer and provided it looks similar to problem 10. All in all, it's just nice to know a little about the destination that we are trying to reach, because any work that gets us to something similar looking means that we're on the right track. Additionally, an answer in the back of the book can also be used to build a method through reverse engineering. Try working the problem forward at first, but after a good college try, and if you're still not succeeding, working backwards from the solution can sometimes put things in perspective. Or even more flexible, and I've witnessed some masters at this technique, would be a squeeze approach. This is where you alternate by working forward from the question a few steps and backward from the solution a few steps, and squeezing or completing the technique in the middle. Of course, these aren't test techniques. Some of our test techniques are found in this video right here. Our squeeze approach and reverse engineering are used specifically to understand a problem and to build an efficient method or approach to solving your problems quickly. So, we have a list of tools or skills needed for this type of problem, and we know what the solution is supposed to look like. Even better, we have the solution from the back of the book. Now we want to gather more information by thinking and asking yourself, is there a long way to solve this problem? I'm not saying to do it the long way, but write down another way you could approach this problem. Think of this extra work as part of your research. By thinking about how the problem could be done in a broader sense, you access more avenues of knowledge, and they're potentially useful pieces of knowledge. For instance, going back to our long division problem as kids, we used the algorithm of divide, multiply, subtract, and bring down. But a long way to do a problem like 396 divided by 5 would be to keep subtracting 5 from 396 and to count how many times you subtracted until you get to 0 or below 0. Another example would be if you were trying to find the area of a circle and you hone in on an estimate of the answer by adding up the area of a bunch of measurable squares within the circle to estimate the answer, knowing that our answer couldn't be larger than the area of a square whose sides were as long as the circle's diameter. As we continue our research and development for a technique to this problem, we are always keeping in mind that adding an extra dimension of knowledge is always an asset in our building and learning phase. Moreover, if applicable, draw a picture, geometric or otherwise. For instance, if you're working on a line and know the slope of that line, draw that line with that slope. The more data points and information you have for a problem, the greater your chances become at developing a technique, a good technique. This is different than preparing for a test, where you purposely build an uncomfortable environment of testing with exaggerated time constraints. Under time constraint conditions, your goal is to limit information to only the pertinent information. Okay, problem 10. Start getting that pencil moving. Start trying to solve the problem, even if it might not be the right technique. It's okay to drive recklessly with your pencil on the paper. Sometimes blowing problems up is how you find ingenious solutions. Moving that pencil on a blank piece of paper will often eliminate ideas while introducing new ideas. Try to think of ways the problem could be easier and then build from there by thinking of ways you could make an easier problem harder. Usually the harder problems just have more steps. Individually, you could solve the steps, but as one big blob, it appears confusing. Solve the intermediary steps one by one separately, and then from those, attempt to cobble together a general solution. Don't be frustrated if it's not perfect. It doesn't necessarily have to be correct at first. The important thing is that your mind is collecting valuable patterns. Stay motivated to solve the problem. You can do this by playing a little game with yourself. This game I played with myself all the time. When I hit a difficult problem, I would imagine that particular problem I was solving was a world problem, like coming up with a cure to a serious disease or building a mathematical scaffold for a bioengineered body part. In this fictional world, solving the problem would better humanity exponentially. Doing this type of work in your head taps into that part of your brain that magnifies creativity. Finally, if you are still unsuccessful at understanding how to get the solution, you then go to a further research and development stage. Here we watch relevant YouTube videos on our topic, analyze the steps of our problem after putting it into a solutions software, or look for a solutions manual in the library or online. After we do all the research online and offline, we then develop. Development doesn't necessarily mean the right answer. That's the best scenario. Development means that you write down in detail your attempt at the problem, your report. In these details include your reasons for the actions you took and your thought process. This is for you to take to your teacher's office hour. The one problem, problem number 10, should be on a paper or papers separate from your other homework, with lots of room for notes and red ink, with your thought process and actions written clearly. This gives a good professor the ability to guide you to the world of understanding, a world where the light bulb clicks on. To highlight this whole process and to see it in action, I think would be a worthwhile video. Perhaps a future video showing the approach while solving a real problem. I thought maybe for a future video, I'd show the process on some algebra problems or maybe a calculus or statistics problem. The applications of breaking down problems is generally the same for all math classes. So seeing one being broken down is like seeing many. Mainly, for you today, think about the points we've discussed and try to implement them. It probably wouldn't hurt to rewatch the video and list the points in your own words. Have patience. Each point has tremendous power, but an incredible study session really starts happening as you learn to melt the points together as one great weapon. All right, it's time now for your solo flight. But always remember, I'll always be here for you as ground control. My hope is that this video gave you some new perspective on how to attack problems, especially those stubborn ones. In your head, train yourself to always attack aggressively and always attack with a mindset that the problem you are working is the most important thing in the world. Attack all problems as if it were problem number 10. Keep organizing your thought patterns and honing in on what the answer should look like. Like a dog with a bone, never give that problem up. Hold it tight till you understand it completely. So completely that you could teach it. From that point, history tells us that once you've struggled but finally understand that problem's process, the challenge will be forgotten. The suffering will be forgotten. Just know that the future you will look at anything similar to problem number 10, and if asked to solve it, you will just smile and say, I can solve that. No problem.